This is the Allen factory, and under a single roof in this facility, we do electronic assembly manufacture, carpentry, final assembly, sheet metal work, all of which are like separate little factories under the same roof. The first place we're going to go into is the electronic assembly manufacturing facility. This factory was actually started as a textile manufacturing facility and was purchased by Allen Organ Company in the 1950s. So this portion of the factory has been renovated, and what you'll see is something very similar to a clean room. It's got its own air handling system, and it's got an anti-static floor, and I'm wearing this special white coat because that's one of the regulations for going into this area. Let's go ahead and see what's happening there. There are a number of different procedures that take place in this portion of the factory. Of course, we manufacture parts for new instruments, but we also refurbish parts for instruments that are in the field and have required service. By offering refurbished parts, we keep the cost of in-field service down as low as possible. After every assembly is built in the factory, it is also tested in this area. And so if it's necessary to repair an assembly that's been shown to have a fault in testing, that's done in this area as well. The machines in the far corner here are actually computerized test facilities, and they will run an assembly through a complete functionality test, and if there are any problems, those computers will produce something that looks sort of like a grocery receipt. It's a list of the locations and the components that need to be repaired. So every assembly is tested when it's built, and then the assemblies, once they're installed in an instrument, are tested again. And components are also tested. So we have triple layer of testing and quality control for every instrument before it even ships from our factory. Years ago, a circuit board like this one would have had one layer of circuitry. And with one layer of circuitry, the components could be inserted into holes in the board and then soldered from the outside. By today's technology, boards like this can have 5, 6, or even 7 layers of circuitry, so that what you see on one side of the board is entirely different from what's going on the other side of the board. At the same time, components have become much smaller and more densely populated on the board. So it's become almost impossible to manufacture boards by hand anymore. And so instead, we're using some very sophisticated machines like the one next to me. It's called a pick and place machine. And just as the name implies, little robotic arms will pick the individual components off a reel of tape and position them on the surface of the board. The surface of the board, before it goes into the pick and place machine, is coated with a mastic, and each of the components is placed on that mastic. After they're placed, the componentry, the assembly, goes through an oven which cures the mastic. Let's see how that works. You'll see the board is moving underneath the insertion head, and the insertion head first takes the individual components off these reels of tape, and then through the control computer program places each component where it needs to be positioned on the board. There the head is taking the components off the tape. Here it's positioning on the board. Off the tape and on the board. After the board's been assembled, it goes through a conveyor belt oven like this one, and the mastic on the board is cured, and the board's complete. The next step is inspection, and that gets a little more complicated because there are so many layers of circuitry and the complexity of the componentry is so dense. Let's see how we inspect something that we can't really visually see. Sometimes your doctor needs to take an X-ray to see what's going on inside of you, and the same thing's true in our manufacturing. The components that we use today have contacts that go directly at the bottom of the componentry and directly into the circuit board. So there's no way to visually inspect them. And for that reason, we use an X-ray machine like this one. It X-rays the substrate underneath the component and verifies that there is sufficient and good soldering at each one of the connection points. Individual components the size of the ones that you see here can have hundreds of soldering points in between them and the solder board. So this step is crucial. The equipment is expensive, but it's necessary to create a good quality product.